In Pre-Calculus 12, we want to keep in mind some key ideas throughout the course. So one of them is this idea of functions, function notation, and the function machine. So when we talk about functions, there is the function notation. So here we have f of x equals x squared plus 2. And we want to think of the function as a function machine. There is an input and an output. So I've shown the input in green, the output in red. The input goes with the x's, the output goes with the y's. So if I have this function f of x equals x squared plus 2, and I have the function notation f of 2, what we want to do is inside that function, we want to put in the value of x. So the value of x in this case is 2. So we're going to put in here, we're going to start with our x squared plus 2. And inside that function, we're going to embed the 2. And we get an output for this. And our output works out to be, in this case, 2 squared is 4 plus 2 is 6. And then we can put this into our table of values. Okay, so these come in pairs now. Our input and output are pairs. I put an input of 4, the output, I'll just do that here. So I have the input is going to be, in this case, 4. The output ends up being 18. So we end up with the y value of 18 that pairs up with x value of 4. So we have this idea of input, output, and we have to make sure we understand this function notation. Whatever is inside the brackets of the function notation is what embeds inside the actual function. So when we talk about the function notation, we can have the inside substitution and the outside substitutions. Again, I color-coded this green for the inside because whatever's happening on the inside actually affects x's. And the red on the outside is what's going to affect y's. So how do we apply this in terms of function notation? Well, we have our x squared plus 2, that's our function. So we have our x squared plus 2, that represents the function. On the inside of it, we're going to embed x minus 2. On the outside of that, so that whole expression represents the function, the square brackets there. Everything on the red represents things on the outside. We're going to times 2 first, and we're going to plus 5 after. Now we can simplify this expression, but we would need to make sure we first understand how we embed this before we simplify it. Now, the other thing that we want to understand is transformation of functions and how it relates to function notation. So we're going to start with some a reference of a parabola that we've already dealt with. Okay. So when we transform functions, we want to transform some key reference points. For parabola, that's a vertex. So when we have this parabola, negative 2 x minus 3 squared plus 6, we learned in grade 11 that we can find the vertex based on that minus 3 plus 6. So we're going to go 1, 2, 3 to the right, 1, 2, 3, 4, 5, 6 up, and that locates the vertex at 3 and 6. Now, this essentially is a transformation. We've moved 3 to the right, 6 up. We also have this factor in front, the negative 2, which indicates that it's going to be upside down in a vertical expansion. And we know that then that the graph is going to be shaped something like this. So these transformation effects of shifting up and down, left and right, and flipping and expanding are things that we want to make sure that we are aware of. We can see it in the parabola. We can extend this idea to all functions. And to do this, we need some reference points. And when we talk about key reference points, we're talking about for the parabola, it's the vertex. For other graphs, it might be something different, but for the parabola, it's a vertex. And we always want to find key reference points to be able to do transformations.